Ladies and gentlemen, what's up? Here we go. Video on section 6, chapter 1. And you can see it's how do you solve and graph compound inequalities. Now, as a quick recap from class, we talked about this. These are our 4 inequality symbols. Yes, we have a not equal sign too, but these are the 4 that we're talking about. And when you're graphing these things, remember, on a number line, it is a closed circle if it's less than or equal to, greater than, or equal to. Remember, I told you there's more writing here on this one than there is on just a strictly greater than, and there's more writing in the actual dot than there is in an open circle. It's an easy way to remember. So that's what you put on any of these, and then an open circle would go on any of these, as a quick recap. As a quick example, here we go. So if we had, like, for example, x is less than -2, notice I already put the open circle on -2, because that open circle means it doesn't include -2. It's not equal to, it's just strictly less than. And then this one's already on the +3 because that's what this says. So, remember what we did next. Oh yeah, a little Beyonce. We had to shade, whether it be to the left, or that cool little dancing song, you know, to the left, to the left, to the right, now kick, all that stuff. Doesn't matter. But we have to get our shade on, people. And remember, this is the thing I told you. Little thing was this. Little part left. It was the way that I'm telling you to remember which way do you shade. Because sometimes you guys look at this and say, well, wait a minute, that less than symbol, it's going to the left, so therefore I shade to the left. That is not always true. No way. Do not ever fall into that trap. If the little part of the inequality is facing the letter, then yes, you do shade left. So if the little part of the inequality, the little part, that's the little part, that's the big part. If the little part faces a letter, then you absolutely shade to the left. In this situation, notice, I know the inequality is facing that way. Doesn't matter. The little part of the inequality is not facing the letter. Therefore, we shade beep to the right. So just a quick recap. Now, these are very simple inequalities. What we're going to talk about in this video is how you actually graph 2 different kinds of what we call compound inequalities. Let's go do it. Here we go. So what's a compound inequality? You can write this in your notes for sure, like you already probably wrote some other stuff, but this is where your notes should most definitely start if you didn't already. A compound inequality, by definition, it is when you take 2 simpler inequalities and you combine them. You join them together with either an and or an or. And you'll see 2 examples down here. This one over here is pretty self-explanatory in that you see, let me use this color I guess, this will work. Bing. So you see this or right there. Well there you're taking a simple inequality and a second simple inequality and you're putting them together with the word or. So it's a compound inequality. Over here you don't see anything, but what's happening is this t plus 4, there's 2 scenarios. It's either that -9 is less than t plus 4. That's one scenario. And the other situation is, and this also must be true, that t plus 4 has to be less than 10. So here's a little hint for you. Anytime you have a compound inequality, it's either going to have the word or it's going to have the word and. So if you don't see the word and, like this one doesn't show the word and, that means it is an and compound inequality. So you need to break it up and rewrite it just like that. This one is already broken up and written into or. So that's wonderful, but how in the world then does it look when we graph these on an actual number line? So we got to solve them first and then graph them on a number line. Now I'm going to give you a couple examples, 2 examples actually. We'll just use these, and then I'm going to show you something how to remember which way they go. So let's rock and roll and do that. So here's this example of the and compound inequality, bam, and I already broke it up for you. So what you have to do is just simply solve this like we did in class. This over here, you just get the t by itself. So you subtract 4 from both sides. You subtract 4 from both sides, you get -13 is less than t. Over here, you solve this by subtracting 4, So that would give you t is less than 6. So you have either t is less than 6, I shouldn't say either. So t is less than 6, and at the same time t is greater than -13. Well, that's really interesting. Now, my graph actually doesn't do this. I wish I had a better graph, but this is -11, This over here, we'll just continue this like this. So over here, we'll make negative 12, and over here, we'll make negative 13. Okay, so forgive the graph, doesn't matter. So let me graph these guys on here for you. I'll make it actually this color right there. So this one, if I'm going to graph it, you guys know it's an open circle on negative 13, which is right there. Open circle. And since the little part of the inequality is not facing the letter, I shade to the right. Little part is not left. Little part is not facing the letter, so I don't shade left. So therefore, I'd actually shade this way, up, that way, the whole way. Now I'm shading it on top of here for a reason. You'll see in a little bit why. So I would shade this number line the whole way up this way. So anything up there would work in this one right there. Now this guy over here, if I shaded it, let me change colors actually. I'll change it to yellow. So this guy right over here, yellow isn't that much of a difference. That didn't work. Pink. Here we go. So this guy right here, if I graph that one, I'm an open circle on 6. And it's, oh, t is less than 6. So since the little part is facing the letter, it's all of those things that are to the left of 6. So I would shade that one down here. Now here's the scoop. You don't shade yours this way. I'm just giving you an idea about what happens because what you're doing, remember, is you're really ultimately up here looking for the value of t that when you plug it back into this compound inequality is going to work. It's not going to give you any false statement. So if I came down here and looked and said, well, wait a minute, if I shaded from negative 13 and above it, all the ones above that to the right, well, that means negative 10 apparently would work because it's in the shaded region up above there, which I agree with you. The problem is if I put 10 in here, I get negative 9 is less than 14 when I put 10 in for t and add it to 4, is less than 10. There's a problem. This right here is absolutely correct. This right here is absolutely incorrect. So that's not a true statement. Now why is that the case? Because this part right here is only shaded for one of my scenarios. This part here, everything 6 down, is all shaded for this scenario. What you need to actually shade for your final answer is all of those solutions where both of these things are shaded. It's actually called this. It's actually called the intersection of these two graphs. It's where they actually overlap. And that part happens to be right here. From this part here, the whole way down. I don't know how I'm going to shade this here. So all of this stuff, so from 6, the whole way down here to 13, all of that stuff. Every one of these right here would be valid solutions that if you plugged it back into the compound inequality, it will work. I know what you're thinking. I don't believe you, Motter. Show me. Okay, I will. So if I put one of those things back in here, I don't know, let's take a simple one. Let's take 0. If I put 0 back into here for t, that would give me negative 9 is less than 4. How'd that come about? 0 plus 4 gives me 0. And then less than 10. Now you look at that. Is that a true statement? Negative 9 is less than 4, and 4 is less than 10. Happy day, oh happy day. So anything in this shaded region, anything in here, anything in here, anything in here, anything there, you get it. Anything in there. This is an ugly graph, but whatever. You get the idea. Anything in there works. So if it's an and inequality, it is all of the stuff in between, if you will, the two dots. Now that's not always 100% the case, but I tell you what, the majority of the time it most definitely is. So that's an and compound inequality. Let me quickly show you what an or is, and I'll show you some examples of how the or actually works. So here's the or example. You see certainly right there is or. You got that, no problem whatsoever. Now, I'm going to give you a quick visual so you can kind of see how these ors are going to look. When I hear the word or, what I think about is this. Check that out. There's a picture of my pops, man. Just kidding. That's not my pops at all. I have no idea who it is. So God bless you, this person, for showing me this picture. But you see the oars of this boat are kind of going outwards. Check this picture out. That's pretty cool. So the oars of the boat are starting in the middle, but they're going outwards like that. Check this one out. This is me, by the way, in my Olympic trials. I didn't quite make it. In fact, that isn't me. If you look really closely, it's not even close, although the cheeks are pretty cool. Good job, dude. So look at the oars. They're going out. They're going out. So when we do these or scenarios, check out what this one's going to look like. And we'll work with this one, of course, together, but here's how we go. So when you solve this one, it's a compound inequality because there's a simple inequality here and a simple inequality there, but they're separated by an or. So when we solve, think of the right word, Motter. When you solve this one, we'll just simply subtract 9 from both sides, which means I'm left with 6x, beautiful, and then less than or equal to, when I take 3 minus 9, that gives me negative 6. Keep on going, now I'll divide by 6, it's no different than what we've done all along, so I get less than or equal to negative 1. Wait a minute, don't I flip the inequality? You only do that, remember, when you're actually dividing by or multiplying by a negative. And in this case, I'm dividing by a positive 6. So this right here is 100% cool. So let's graph that down here on my number line. It's a closed circle because it's less than or equal to. So negative 1 is right there. Closed circle. And then little part is facing the letter, so therefore I, and you would too, you should, is going to be shading, beep, yeah, down this way. Looks just like that. So it's a closed circle right there on negative 1, and you're shading to the left. So it looks exactly like that. So, now what? Well, let's do this one over here. Let me change colors. I'll use pink, whatever. So I'm going to add an 8 to both sides here, add an 8 to both sides. If I'm going to get rid of this and get x by itself, so I'm left with 3x is greater than, let's see, 13 plus 8 is 21. So now I'm going to divide by 3. Inequality stays the same because I'm not dividing or I'm not multiplying by a negative. These cancel out. I'm left with x is greater than 7. So I have my other side of the inequality. So either x is less than negative 1 or x is greater than 7. Well, let's do that. That means I'm going to put, it's an closed circle, open circle on 7, open circle on 7. And this is not facing the letter. So therefore I must shade to the right. So when I shade to the right, whoa, that's going to look like this. I shall shade to the right. Shade to the right. Now what I want you to notice is this. Look at which way those graphs are going. This one's going to the right. This one's going to the left. Dare I do this again? So here would be the middle. Here would be your shaded to the right. Here would be your shaded to the left. All of these or situations look like oars of a boat. So as a little hint to you, you're welcome, anytime you see the word or up here, that means you're going to have most like 99% of the time, not always, I can't say that, but the ones that we're going to do, they're all going to look like that. If it's an and scenario, then great. Then you're going to have something where you're shaded in, whether it's an open circle and closed circle, don't know, but ands look like that. Whoa, ors look like that. So you are welcome. Good luck with this. We're going to practice these in class, and I hope you have all of these. Go back and review this if you need to. You need to make sure for sure, I just said for sure twice, you need to make sure, for sure, that these examples are in there. So we'll see you in class. Have a great night. Later.